Check, check, check. Okay. I can see my slides. Cool. Is it too loud? Is it okay? Too loud? It's okay? Okay. All right. I guess we're going to go ahead and get started. I'm the first speaker, Chad. So thanks for joining us today. Usually there's like an MC or something, so I'm just going to fire off. Okay, so my name's Chad. I currently work for Oracle. I was previously with a company by the name of Iron.io, and where we founded that about 6 years ago. And then before that, hold on, sorry. There, yeah. Before that, I was founding partner of Epoxy, which was a consulting company, and I was just telling this story. A big part of the reason that I got into serverless computing is because we built a platform that was basically looked a lot like Amazon Lambda, and that was around 2009, 2010. We started writing articles. Sorry, I'm just going to fidget with this for a minute. We started writing articles called "The Future is Serverless," even though it was like kind of a stupid term, still a stupid term, and it was just something that we thought was funny and marketable. And it turns out that everybody thought it was actually going to be this whole category of computing. So go figure. Before that, I started a company in college. So fast forward to now, a company was acquired and we joined Oracle to build out a serverless platform on top of the Oracle Cloud and do a bunch of open source stuff as well, a lot of which I'm going to demo today. Okay, so that's about me. Oh yeah, and I play guitar in a band, which we're kind of in hiatus, but yeah, that's me on the guitar. The only instrument that's really worth playing. Okay, so first of all, who in the room has used serverless or can define it and used it? Okay, cool. How many of those is it Amazon Lambda? Or how many people have used something other than Amazon Lambda? All right, okay, that's 3. I always have to start with a definition. And there's a whole lot of like noise out there about serverless computing. It was one of the biggest trends of 2017. And I think for good reason, because it allows developers to really not think about any of the stuff under the code level. So you're not thinking about the infrastructure, you're not thinking about the scaling, load balancing, networking, and all that stuff. You're really just writing code, shipping code, and moving quickly. So the way that I define it, and challenge me, is that serverless is that abstraction layer, this concept of serverless computing. Serverless architecture is when you use a number of different services to achieve that abstraction layer. So when you're using things like database as a service and load balancers as a service, LBAS and DBAS, functions as a service for compute, which brings me to the final point. Functions as a service is the compute component of a serverless architecture. So that's pretty broad and generalized definition that I've been going with. And I'll kind of cruise through some of these slides because we want to get to something more interesting because this is a Docker meetup. But why serverless? I think if you haven't bought into it yet, at least give it a shot. It's really, really, really empowering once you start using it. And that's really why my co-founder and I built that system back in the day, because we wanted to ship code faster for multiple clients and we wanted a multi-tenant service. And we didn't want to think about all this cloud infrastructure. And you have a lot of opportunity because you're able to scale this stuff like very big, and it's really cool. So it's powerful because you get transparent and limitless scaling. It's fast because you're able to iterate really quickly on your code, and it's cheaper because you're really only paying for 100 millisecond increments of the time that your functions are executing. In fact, I'm seeing that you'll probably see this be dropped to about 5 milliseconds, maybe even 1 millisecond, because you can save a lot of money with really, really short-lived requests. Okay, I'm not going to talk about what a function is. I think most of us probably understand, but it's basically a little bit of code. It's a small bit of code, self-contained. Throw it into a container. That's what we believe a function is. Because this is the Docker meetup, I want to talk about containers and functions because there's a lot about what the topic of the talk is today. Containers, we all know what containers are, I hope. We're here, we want to hear about them. The difference between containers and functions is it's not that they're different, it's that I think a function is a specialized type of container. That is actually what it is on all the different platforms. With the FN platform that I'm going to talk about today, it's a special type of container. It has properties that we can expect and we can reason about. So it's short running, it's ephemeral, it's stateless, it's invoked, it's single purpose, and it's self-contained. If a container has those features to it, or those components to it, then we can call it a function. Because once you know that, then you can suddenly have a lot of power over that specific container. You can control that function, you can reason about it differently, and you can use as a service platforms to be able to scale this thing. And I'll show you a demo of FN of how we basically extend the functionality of containers to provide a serverless type experience, but the power of containers as well. So what is the FN project? I'm wearing the shirt. We launched it about 6 months ago. Let's talk about it. It's open source under Apache 2, 100%. We've got over 50 contributors today, 2,500 commits to it. It is a functions as a service platform that you can deploy on any cloud and on-premise as well. So it is serverless to the developer. Now, someone does have to operate it, right? I mean, there's this whole Kelsey Hightower thing going on today on Twitter, if you notice. But he says if you have to deploy a Kubernetes cluster and then a functions as a service thing on top of it, and then deploy your function, don't call it serverless computing. Now, I get it, but those roles are generally different, right? Someone is eventually going to operate that cluster, and someone is going to eventually develop against that cluster. If you're developing against it and you're not thinking about it, and you're not thinking about the scale and the infrastructure and everything underneath, it's a serverless experience for the developer. And of course, literally 200 tweets later, that's kind of where it's ended up at. So the FN project is an open source platform that enables you to do that. Oracle will eventually have a service. I cannot give a date to that, but it's going to be sometime this year. Oh, and it's independently governed with plans for a foundation eventually as well. Okay, so what's the developer experience look like? An FN function is just a small piece of code that we containerize and we put into a container, and it gets its input via standard in and the environment. So everything it operates on, it gets via standard in the environment, and then everything that goes to standard out is returned back to the user, and then everything that goes to standard error is stored, or you can pipe that in, you can put that into syslog and store that somewhere so that the developer later can actually access that log information. The system takes care of everything else. So really all you have is a function which is in a container, and it operates on standard in and an environment. We have a CLI, and this is where a lot of the power comes in. If you use the CLI, it really comes down to these 5 commands. Init, run, test, deploy, call. Init, run, test, deploy, call. Init will give you some boilerplate, so it'll give you a function out of the box. Run will build the container using the code in the current directory, and it will execute that function, or run that container essentially, but execute that function. And then test will also build that container with the code, but it will pass in some input via a JSON file that we give you with FN in it. So you can basically give it a set number of inputs and then define a set number of outputs, and it will check those inputs and outputs. That's actually really nice because we're not actually running the tests inside the container, so it doesn't matter what the code is or what is running inside that function. It just takes the input and the output and matches whether you're getting what you expect out of that container. And then FN call is a wrapper around curl that executes that function on the remote server. So FN run and FN init are local, and FN test is local. FN deploy will take that, also build the container, but that will push it to the registry and then register that with your with the FN cluster that's running that you have configured. And then FN call will call that. Let's talk a little bit about FN deploy, because this is where a lot of the cool stuff happens. What FN deploy does is, and I'll show a demo of this, step 1 is it builds a container. And actually, if you go back, all of this is around containers. You notice I talked about building containers, building containers, building containers. That's because containers gives us this amazing way of packaging up in a standard way code that we know how to ship it around, and we know that it can take advantage of the ecosystem. And there's a lot of benefits to using Docker and containers. So everything we have here is based around containers. So deploy will take it, build it, bump the version, push it to a registry, and then it will create a route, which you then can access to trigger your function. So you can set that up to webhooks, or it'll give you a URL that you can map to an API gateway. So that's sort of the FN deploy process. Additionally, we have FDKs. FDKs are called function development kits. We have them in all the major languages. Again, because FN supports containers natively, any container can be your function. However, if you want to write inside one of these languages here, we give you a really easy way to handle the HTTP stream that comes in through standard in, which is pretty error prone if you just deal with HTTP. So we have a JSON protocol, we have an HTTP protocol that we can handle, and this enables you to build something called hot functions, which I'll demo in a second. So this is what makes it super, super easy to work with FN. And then finally, after you deploy and you're executing your functions, this is how you debug them, FN calls and FN logs. This gives you the call list of that function, and you can get the logs from a particular invocation of a function. And then inside FN, we're actually using open tracing. We're running a bunch of spans across basically everything, and then we can pass that across to something like Prometheus or Zipkin or Jaeger or something else, and then ultimately view that in Grafana. Finally, we have a UI, open source UI. It needs a bit of work, but it gets the job done to sort of get the basics out there. And again, this is all open source, so definitely encourage you to take a look. Okay, so I'm gonna just switch over to a different terminal and show a quick demo. All right, let's make this a lot bigger. How is that? Oh, no, I don't know if it goes much bigger. How's that? In the back? Okay. I have nothing. What? I have something now. Func.go, func.yaml, and test.json. Let's run FN test. Builds the container, 2 tests pass. And if we look at our test.json, that's really big, but you can see that we basically have 2 inputs and with an expected output. So basically when I ran FN test, I'm testing against both those tests and they both pass. So then I can do FN run. Again, building a container locally, and I get the message, hello world, which is basically what the func is that I got here. So if you look, it's just a simple Go program that takes an input, decodes it into a variable, and then says hello, whatever you pass into it. If you don't pass anything into it, it says hello world. It's pretty straightforward. So then I can do something like echo. Okay, so that looks like JSON, and I'm actually going to pipe that right into FN run. And again, because we're getting our input on standard in, it takes standard in, executes the function, and then returns the JSON hello Docker meetup room. So now I can do something more interesting and do FN deploy --app demo. So we're actually hiding the Docker, well, it'll show the Docker push, but we're hiding the Docker build. You can actually get the verbose. If you do verbose, you can see all the Docker output and everything. So again, this is all just Docker that's wrapped inside our CLI. So now that we have that, we can do FN call demo hello. Now we get hello world. And again, if we want to do FN call demo hello. So this is actually really cool. I'm taking JSON, I'm echoing it, and I'm piping it into a remote call of the function that's living on a remote server that is running on top of a Kubernetes cluster inside Oracle Cloud Infrastructure. But this could be anywhere. And you can also run it locally on your laptop. If you type FN start, that'll fire up your local server, so you can test against it there. Okay, what's next? So okay, now that I've seen that, we've been talking about Docker a lot. Well, let's bring our own Dockerfile. Let's get rid of our func.go because we don't like Go, and we just want to deal with Docker. So let's create a Dockerfile. Everyone should be familiar with Docker. This is just the hello world image that comes directly from Docker Hub. I had nothing to do with it. So here's our func.yaml. It's our version, runtime, and entry point. We don't need an entry point because it's a Dockerfile, but we do need the runtime Docker just so that it knows. And now if I do FN run, I get just the output that's directly from that Dockerfile. So I basically took the hello world off the shelf and made it my function. It probably doesn't know how to accept an input, so it doesn't matter what I pass to it. And then one other cool thing is I do have a demo. I get a route to this. Oh wait, demo hello. Actually, let's deploy it. So now I'm taking that same function, bumping the version, passing it in, and then when I refresh the screen, now I get it through my browser because I actually get a route. You can't really see it, but it's api.fnservice.io rdemo hello. That's R is for like user routes and user namespace. And then demo is the name of my app, and hello is the name of my function. and I get back the same response. It's pretty cool. So one other thing I'll show you, because this will set up a part of the demo I'll do later, is, let's see, hot. All right, so this is a hot function. Currently, there's two modes that you can run your function in, hot and cold. And then we also have sync and async, but they're independent. So a cold function, what it'll do is when you invoke the function, it'll spin up a container, respond to your request if it's a sync function, and then that container will go away. You hit it 10 times, you're going to spin up 10 containers, and then those 10 containers will go away. A hot function, because Docker can take some time to spin up the container, and if you're expecting a response in, say, 50 milliseconds, but your container takes 400 milliseconds to spin up, it's going to be a pretty bad user experience. So hot containers is something that keeps that container running and will return a response. It will continue to stream in to the container that's running across HTTP, and that's what our FDKs will help you take care of. So you can get a faster response. So let's do, let's deploy this. We're going to deploy our hot container, and I'll show you, to make it a hot container, all you got to do is just change the func.yaml, I think to, I changed the format to HTTP from default, and that automatically turns into a hot container. And then I have a vendor directory in here because what I did is I vendored our FDK, and I use that. So if you look at the code, it looks a little bit like this. So I import in fdk.go or fdk-go, and then instead of having the function inside the main func, I actually do an fdk.handle, and this now suddenly looks a lot like, if you're familiar with Lambda or Azure Functions or something like that, we have a handler that gets a context in a reader and a writer, and every time it knows how to deal with the request that comes in, it does basically the same thing, which is like hello world, and then it returns that. So if I go to, let's actually open up, sorry, where's developer tools? Window. Here we go. See if this makes sense. Okay, so you probably can't see this, but I'm going to go to hot. All right, so you can see, if you can't really see there, 532 milliseconds is what it took that container to run. If I run it again, 100 milliseconds, 99 milliseconds, 97 milliseconds, 160. So this is actually, it's taking 160 because basically I'm going to Ashburn, Virginia and back. So I think that's like speed of light plus plus. But it went from 500 milliseconds to 160 milliseconds because we're not dealing with the spin up of that container anymore because the hot function is running. So that's kind of the magic of hot containers. Okay, let's go back. Any questions so far? Yeah. Yeah. So I think I understood the question. So the question is, along with hot containers, how do you get sort of that usage-based pricing model, and how do you get the benefits of serverless? Yeah, good question. So we don't charge for our service yet, so it's all free, open source. But I got a couple slides coming up to talk about how we do the scheduling for that, which I think will give you an idea of how we look at dealing with how to optimize around hot containers and ensuring that we only have them around when someone needs them. So hopefully that will help. I think that might be the most interesting part of the talk, but you guys tell me afterwards. I'm kind of road testing some of these slides. Okay, few slides on if you're an operator. This is what the architecture looks like. We have an FnLB load balancer. It could be any load balancer, but the FnLB is smart because it can continue sending traffic to a particular node that has that function already hot. Then you have your FN servers, and then you have a database, a queue, an object store, and a registry. And of course, you're going to use Docker Hub or Trusted Registry here. And then these are all pluggable. So if you want to go use, some other enemy's container registry, you can. If you want to use, we support MySQL and Postgres and Oracle, not Oracle DB yet, but we will eventually. And then for an MQ, Redis and Kafka and all that jazz. The FN server basically handles all the CRUD operations. So when you do an FN routes update or FN deploy and all that, everything is going through the FN server. Also requests go into the FN server. It kind of handles a lot of the magic for you. The FNLB is a fast load balancer based, it's just a Go load balancer that helps route traffic to the right node so it can be intelligent. There's a bunch of thoughts where we take this, but that's kind of beyond the scope of this talk. We'll skip this one. Supporting services, yeah, we talked about this. And also, because we use open tracing, we have an extension where you can pipe everything out to Prometheus, so you can get really fancy graphs and stuff like this for operators and stuff. It has a really nice, elegant design, so we keep the core really lightweight, and you can use extensions for things like all the different databases, all the different auth systems you might need, all the different logging and metric systems. So that way you can keep the core really tight. Okay. This is a little small, I apologize, but I'll talk through it. So I'll cover this real quick, and then I'll get to the scheduling portion of this. So a request comes into our load balancer, and the load balancer decides where the best node is. Okay, it does that because it will get back pressure, and it kind of keeps routes and uses a consistent hashing ring to be able to know where to go. And I won't get into too many details there, but it will pass the route into the router API gateway, and then once it does that, it will check the data store to see what the route is and where we should send it or where we should get the code. Then it will spawn a container, and if the container exists on that node, it will use the cached image, assuming that the image is tagged with the version that the request is coming in. If it doesn't exist, it will pull it from the registry, and then it will spawn a Docker container using Dockerd and Docker. It will execute, it will return back to the user, and it will store all of your results in both the database and the object store. That's like kind of the high level. Async is essentially the same thing, except there's a little agent or a little puller that's pulling the queue and asking for work. Whenever the server becomes available, it will pull work off that queue. So that's the async aspect of it. Okay, so your question was around scheduling. I think this is sort of the heart of like where this sort of intersects with Docker, other than the fact that like FN is 100% container native, and that's a really, really cool aspect of it. But the scheduling is sort of an important problem, or an interesting problem to solve. So if the questions get too difficult, there's a guy in the back who helped build this, and he'll answer them. So basically, this is a snapshot in time. This is T0, and I'm going to go through T6, and we'll see if there's questions. So the blue is the Go app, and the orange is the agent running inside that Go app. The blue are a set of Go routines that are running, and then the box here is a queue, and here is our Docker daemon or Dockerd that's running inside this. So when there's no requests coming in, this is kind of what it looks like, more or less, except we don't have these Go routines. These Go routines, essentially, this is a slot manager. This is what figures out what containers we have and availability and all that. The resource manager is what says what the availability of memory and CPU is on that particular machine. And then the hot container launcher is what communicates with Dockerd to spawn containers. So these three things all work in conjunction. Okay, it's about to get a little crazy. So 4 requests come in. Okay, bear with me for a minute. 4 requests come in, and the calls come in, and obviously we have no containers running. So actually, I'm gonna go back. Your question was about serverless and resource management. So in theory, at T0, there are no resources being consumed other than this one node that exists, right? Just kind of waiting. I'll talk about Kubernetes in a minute. This could be a Kubernetes pod that's running this node. But so if it's a pod, then in theory, that pod could be doing something else until you actually need it. So there's nothing going on. The resources are 100% available. 4 requests come in, and the calls look at the queue. There's no available containers. And by the way, these are hot functions. Okay, so then they talk to the slot manager, and then it says, oh, there's nothing available. So it talks to the resource manager, and the resource manager says, oh yeah, we got resources here. Let's go ahead and serve these requests. It spins up 4 container, or it talks to the hot container launcher, which uses Docker and Docker to spin up a container, or 4 containers, I should say, on this node. So now we have 4 containers that are in the queue, and they're spinning up. So that's T0. Nothing's actually processing yet, so the user is technically waiting. T0 hopefully is a short amount of time. So T2, or sorry, that was T1. T2 is, okay, now those functions become available. The calls the slot manager pulls the container off the queue and it starts executing our code. So now our code is actually executing, the containers are running, and in theory, we're charging our customers for those 4 executions. Okay, so that's T2. Now, in T3, those 4 containers finish their work, no other requests come in, and now what happens is those containers are idle and they go into a queue for a certain specified amount of time. On that queue, they will sit there until they expire. So if we look at the next one, 2 of those containers expired at T4, and so now we have 2 idle containers. And so a lot of the like resource management, I mean, this is not insanely intelligent right now. I mean, you can see all this in the code. Nothing is hiding. So if you look at it, I mean, it works really well, and we've been able to load test it, but the project's been around for about 6 to 8 months or so. A lot of work going into it, but there's a lot of work we can do around this kind of scheduling and resource management. But it's getting pretty good, and we're hoping to GA the OSS in the next month or 2. Okay, so 2 of them die, 2 of them stay idle, 4 more requests come in. One of them is a cold function. The cold function spins up its own container, which then goes away. These 3 are hot containers. We had 2 idle. The 2 idle ones pull off the queue and they start running. And that happened right away because those containers were literally waiting for an input to come into it. And then function 6, or container 6, has to start, and now we're waiting for one to start, puts it on the queue, pulls it off, and that's sort of the broad overview of how it works. Then, T6, 1 of them finishes, 2 finish, go into the queue, they're idle, everything is handy dandy, and then T7, as everything is done and we're back to the original state because no more requests come in and there's no more resources being used. Now, this doesn't talk about VMs at all because this is just a snapshot of a single node, but in theory, what will happen is when it becomes super busy, let's say these 4 containers are taking up all the memory or all the CPU or memory of a machine, then this resource manager will communicate with the API gateway, which will send a 503 back to the requester, which should be the load balancer. And the load balancer, because it's so smart, will say, I've got a 503, now I need to start spinning up more nodes. So I'm gonna maybe talk to like the Kubernetes resource manager, or I'm gonna do something to spawn more machines underneath. And in theory, that could be pluggable to any infrastructure. So that's how we deal with needing more infrastructure. I do not think that's built yet, but so we're actively working on that. But we do get 503s properly. Okay, so I talked about Kubernetes. Yes, question. Yes. Yeah. Yeah. Yes. I don't know the details of how it works. I haven't dug in too deeply. But I know Alex, I know OpenFaz. I think he doesn't admit it, but I think a lot of inspiration came from Iron Functions, which is where we actually forked our project from. We created Iron Functions about a year and a half ago. I don't know the details about how he handles it. So I can't give an accurate comparison. But I'd be interested to take that conversation offline. So also a good project. I don't have too much detail about that. Your first question was request comes in, just to repeat for the audience, request comes in, node's got a hot function, but the request gets routed to another node. If there's no container running, it will have to spin up a new one. So you will have to incur that penalty. That's why we have the smart load balancer, the FnLB, which knows to continue sending traffic for that particular route to that node until that node is starved. And then it will start sending to another one. Kubernetes. FN is scheduler agnostic. So we support bare metal, we support Kubernetes, we support Mesos or Swarm or anything underneath the hood. If you can use any scheduler that you want. We get a lot of questions around Kubernetes. We run Kubernetes internally at Oracle. We've got a bunch of Kubernetes services, and we will probably operate FN on top of Kubernetes. but we do not take advantage of the scheduling capabilities of Kubernetes other than maybe have it manage our infrastructure. So lots of people say, why is that? I mean, one reason is we started to build FN a while ago, and the world really hadn't necessarily choosing Kubernetes or as the one orchestrator to rule them all or whatever you want to say. So I guess that's one reason. But I don't believe that that's going to be deployed everywhere. I don't believe that that's the only answer out there for running this stuff. So why would you got to be careful if you tie too deeply to it, but that's another story. But really the reason now is that we don't kind of build more work on it is because, I'll go to the next slide. It comes out of speed and scale. If you think about the way that functions as a service runs, these things are running for oftentimes like, 100 milliseconds. Like I showed you that one function, that was 100 milliseconds, and it's spinning up a new container every single time. Imagine if you have 10,000 customers with dozens of functions each, all executing functions at scale. You're talking about millions of containers. So I think they talk about Kubernetes, and I don't want to challenge this because I'm not the Kubernetes expert, but when you start launching millions of containers and they're all like super short-lived, it starts to run into all sorts of problems. One, trying to send all of this like resource orchestration through a single Kubernetes master to do like allocation and everything, like that in and of itself is pretty scary to me. Also, the pod launch time alone is too slow. Now, of course, we could do like hot pods and stuff, but then we're basically just like recreating what we're doing with hot containers anyway. So that's one reason. And other reasons, like we're running out of network space, and it just starts to fall over when you start trying to do this at massive scale. So that's one of the reasons we don't use Kubernetes as like the only orchestrator to do this. There may be some extension work to do that if anybody's interested in kicking the tires, but for now, we have our own scheduling system. I don't have a whole lot specifically other than what I've said before about Docker, but just a few tips that I thought I'd throw in here. Storage stuff. We did try lots of different storage drivers, and lots of them fell over. Overlay 2 was the only one that was reasonably tenable to use, and it works pretty well for us. So ButterFS was really slow under load, but I don't think they recommend it for high scale like that. Overlay 1 ran out of file descriptors and blocks, so we had some issues with those, so I thought we'd pass those along. And then the only other thing is lots of people ask why Docker and Docker and not talk directly to the Docker socket or just spawn sibling containers. There's actually two really big reasons that we chose to do Docker and Docker. It's actually fairly reliable. The first one, because we were able to contain the blast radius if something happens, because inevitably, you have to remember, we're running other people's code. It's not like our code that we've ran through some QA process. Like you could give us anything and we'll run that. Tens of thousands of customers are giving us dozens of functions and we're gonna have to run this stuff. Stuff goes wrong and Docker sometimes doesn't know how to deal with it. I mean, it does happen. And so when those Docker child processes die, basically systemd can just kind of kick the FN server and it will refire up those containers and everyone is, more the merrier, except for that one container that died. If we were spawning containers, directly to the Docker sock and one of those killed the Docker process, then all of the containers die on that node and everybody that was shared on that node then ends up dying and that whole machine ends up dying. And now we've got a big cluster F of problems, which we ran into a lot of problems running Iron Worker at my previous company with, because nobody likes their code to die because of some other customer that they don't even know. And so that was a huge issue. The other one is that because we're running customer code and because we don't necessarily know where the system is going to be deployed, we want to be able to control the Docker version on both the parent where the system runs and the child where the code runs. And that might be different. Otherwise, it would be the same. And we might have to deploy an old version of Docker that runs customer code, and that can be bad. So that's kind of the two main things about Docker that I want to talk about. And the final thing is, with 5 minutes I have left, I think, is we have a system called FnFlow. I encourage you to take a look at this. It's pretty interesting. We're sort of thinking about where the world is going in terms of taking serverless to sort of broader application architectures and use cases. And what FnFlow is it's a system that allows you to build higher level workflows and orchestrations with functions in the language of your choice. So rather than sort of maintaining big long JSON scripts and like this one changes this one or YAML or whatever, which by the way does have a place in the world if it's a pretty simple app, once you start to get more complex, it becomes pretty hairy pretty quickly. So FnFlow is a system that allows you to do this, but particularly for at the language level, what we did was we took the completable future API from Java 8, and we implemented that using Flow. And we're doing that with Go and the other languages as well. And so what that gives you is a way to sort of abstract out your hard-coded invocations, which I'll show you in a second, and sort of build those workflows. I'll show you a quick demo of something I call Vista. Basically what Vista does is it takes images from Flickr of cars. It'll detect the plate using OpenALPR library, which is open source, which, by the way, if you don't have containers as your function, it is such a freaking pain in the ass to get some of this stuff to run. Like OpenCV, OpenALPR, like that stuff is not very friendly to do locally and also in the cloud the same way because there's so many dependencies. But when I built this, or when I had help building it, I basically just said, oh, OpenALPR, there's all these instructions. This is this long, and at the very bottom it says, or use this Docker container. That was like magic because you know what? It just worked. Okay, so then plate detection will detect the plate and the characters of the plate on the car. It will pass that to a draw function, which draws a box around it, and then it will tweet the value of the plate and also push to Slack. Now, each of these red arrows, when I first built this, was like literally an HTTP call from one function to the next, which was just making like a remote call to the server to call the function. But imagine, you know, this is pretty simple, but imagine if this got pretty complex and we've got all these hard-coded invocations everywhere and somebody changes something, everything goes foobar. So what Flow does is it takes those, turns them into like kind of completable future, nice code, moves it into their own function, which we call a flow function, and suddenly you have a much cleaner way to design that workflow. I won't go through this because it's really small, but basically these are like the bits of Flow or of Vista using Flow. We invoke the scraper and we get back a result from the scraper, which is what pulls like 20 cars from Flickr. It then does a then compose, and again, this is all should be familiar Java code, and we're working on Go as well. It will iterate across those. It will then do a plate detection and a draw detection, and then it will take the results of that, and it will do an all of, send to Twitter and Slack, and then at the end, when complete, it'll tell us whether we finished or not. That's actually something that's pretty hard. When you know, how do you know when you're done with a particular workflow? Like these are hard things to design in a system. So something else really cool about Flow, which you can't really see here, is that like if you have a variable like scrape result.id, that actually gets reconstituted all the way down all these invocations. So even though we're spinning up hundreds of functions across like, could be thousands of nodes, could be different clouds, we're actually capturing the heap in the stack and passing that in through the whole flow. So that's something that's really cool. And it's totally not possible with hard coding this stuff together if you've kind of tried to build this stuff before. Okay, so I'll try and see if the demo works. Patrick looks relaxed, so I think his works now, so pressure's on. Okay, so, oh yeah, here's the functions UI. Ignore this something went terribly wrong message in the top right. Lots of functions, but I won't show that. So here's the experimental Flow UI. Where's my term? Okay. Services Flow. Again, Java programming here. I have a func.yaml. I have a payload, so let's just show you the payload. Actually pretty straightforward. I have 3 values I'm going to pass in, and if you remember, I can just do, I'm going to pipe the payload right into fn call Vista flow, and then once I kick that off, I get a flow that starts to run here, and this is a graphical representation of this flow running. Oh, it's running actually so fast that you can't really see what's going on, but basically I'm pushing images into Slack already. So when I run this locally, it's actually really slow, and I get a chance to actually talk about it, but I'm running on our cluster. So that's finished, and it also tweeted too, which I think we get a bunch of new tweets here. 13 seconds ago. Watch out for this guy. He's Tellard. Actually, we can't even tell. Let's see. It's pretty good. I mean, you know, it's not perfect, but again, I took this off the shelf. If I were like the CIA or something, I'd have better functionality there. But basically, I'll just show you real quick. So at the very top is like the original invocation. Then it starts to fan out, the scraper, then the detect, then the draw, then the alert, then the post to Slack. And what's really cool here is I can take like any particular node here. We call them nodes, but any particular function invocation. It shows you the chain of how it got there. And I can also look at all of the different call logs all the way through the entire chain. So I can take a look at like, oh, let's look at this particular alert. And it was called from, it's bigger. It was called from this output here with then compose. Then it was called from draw because we're calling from Minio. Then it was this detect plate all the way down the stack to the scraper and the original flow call, which is when I did the FN call, you know, this to flow thing. So that is flow in a nutshell. Again, all open source under the FN project, so feel free to take a look. And I have 1 minute left for questions. I think that's everything. Yeah, thanks. Yes. And I'll give you all 1 minute to star the project on your mobile phones. No, I'm just kidding. No, I don't need it. I'm all good. Are there any more questions?
Hi, sorry. So the other question is about where, my question would be, where are events? Because the functions are great, but when you integrate them into events, they are so much better. And do you have any integration?
Good question. We are actively discussing what that looks like, but I mean, the easiest answer there is that everything, no, hold on. So everything gets a route, and I don't even know where it's at. Okay, so everything gets this route here, r/r/myapp/myfunc. You can use this anywhere to trigger this function, and anything you pass into that, you can post to it. Anything you post to it's gonna come in on standard in. So you can create events anywhere that you can send out a REST call. We are working on what a more elegant sort of eventing system looks like, but you could plug this into pretty much anything today. And of course, when we do launch the Oracle function service based on upstream FN, we will be pre-integrated with all the other services, just like the other cloud providers.
You mentioned the use of Zipkin. Do you do instrumentation, or how do you?
Yeah, I believe we replaced everything with open tracing, which is doing, so inside, and you can see this, it's in the code. We basically, and Reed can maybe answer more complex questions about this, but we put spans around everything, and then we label those, and then we'll basically pass those off, and then we have an extension, which is, I think we call it a collector, and that collector can then take the results of those spans and put those into, you know, any format that you want. We have an extension that was built for Prometheus, because that's what we're going to use internally. And so all of that stuff is built, and you can actually see that code today. That's how we do that.
And you're moving to open tracing or something?
I think so, yeah. Okay. We moved everything in the core code to open tracing to kind of like not put implementation code from Prom or Jaeger or Zipkin. And then you can sort of choose those as extensions to collect that data that comes out for open tracing. No questions for you? No. You're going to ask a question? It's an easy one. Are you nice today?
So as a user of this, as a developer, so if I decided to build the application you just showed the way you did it, imagine that part of your functions, I'm thinking I want to reuse some other place, right? So in your experience, you see that that's actually a benefit. And then more importantly, let's say, for instance, that rounding thing, right, needed to change. Maybe I have multiple versions. So how do you manage that? So in other words, like, what's the advantage? Because I could have written that code, you know, in one application, make multiple calls. Mm-hmm. But decomposing it into function was because those functions potentially could be useful, right? So in your experience, does that actually happen?
Let me see if I can unpack that question. So are you talking about the Vista Flow code that I showed?
Yeah, just use it as an example.
Like, what's the advantage of that versus just writing a program that does that?
Yeah.
Well, the biggest reason is if you look at FnFlow here, this code, you get this one app. Man, a lot of clicking today. Sorry. What the hell? Okay. You get this one program, and you can reason about it like a single program. So you can use JUnit, and you can use your IDE, and you can set breakpoints, and it looks like one program. But like, what's actually happening here is it's coordinating with the flow system, and it's spawning like thousands of functions. So those functions could be running across thousands of nodes, and the The FN server is really where you're going to get a lot of that advantage because it's going to spawn up containers and do all the resource management. It could be running in multiple clouds. It could have a lot of intelligence built in. Like maybe I want to spawn these functions somewhere today, but I want to spawn them somewhere else tomorrow. So you get sort of all the under the abstraction layer advantages. You could do this with a single program. Like you could write in like an HTTP call or
Go far. Right?
Yeah. Yeah, I mean, you could do this yourself, but then you have to manage a lot of that resource management. You have to build in all that stuff. And like that's sort of the advantage of using a system like this that can break those individual functions out and then spin them somewhere else. Also, you can take each of these functions. So now, and this is kind of the overall vision of like why you would sort of decouple these things is now that they run individually, you can use this draw function elsewhere. You can use this plate function elsewhere.
So in your experience, does that happen? Because you have a production
Yeah.
doing this?
Yeah.
Does that actually happen? Do you look to see if there is function that actually being used? Like this part of the company started building functions and because that's sort of like the dream, right?
Yeah, I mean, is there anybody from Netflix in here? I just know because I recently read an article about this. Like they have a really nice system to manage dependencies and share dependencies inside containers for other teams. And they have a whole way to track like what version people are using and what the load is and when they can retire old versions. So they're doing it internally. Now, not everybody is like at scale like that. I think it hasn't become easy for people to do this yet. So I think that's like where we want to see it go next is make it super easy for people to do. And that will unlock a lot of possibilities, I think. Maybe one more question if there's, yeah. Oh, using which pattern? Reactivix? I'm not familiar with that. I'll have to defer that question. I don't know. I do, okay, I'm not gonna flip around anymore. The UI is like super experimental still, so Flow is not like gonna be in GA or anything soon, and the Flow UI will probably change. Most everything is built in Go. The reason that we chose Java first is because obviously Oracle has a really big influence internally around Java, and the Java team was really, really like gracious to contribute a lot of this completable features work for us. I don't know what slide I'm on. So that's why we started with Java, but ultimately it's not like particularly a Java thing. Yeah, yeah. There's a lot of conversations internally with like Brian Getz and his team to talk about how we sort of take this to the next level. So if you want to engage with people there that are talking about it, we'd love to have you contribute. Cool. Okay, thanks.
Like that? Okay. I'll go. Right. Okay, so let me make that.